Hello, MJ7 NLK here and welcome back to the channel. If you're already a subscriber, then I would like to thank you for your continued support. If you haven't yet decided, then please click the subscribe button as it really does help the channel out. Today we are going to be discussing power, the different types of measurement and how they relate to CB radio. We will be using 3 different products used to measure power and comparing them to see how the measurements differ. Let's get the disclaimer out of the way first. Modifying a radio is at your own risk. You will have legal obligations in your region with regards to radio transmissions, licensing and power outputs. You should always ensure that you are not causing a nuisance and, more importantly, not causing radio interference or distress to others. Please do not break the law in your region. In order to measure the power output of your radio equipment, you need to purchase a meter that covers the frequency range you are using. Check to ensure it covers the frequencies before purchasing. There is no point in trying to hook up a power meter designed for UHF frequencies if you are attempting to measure HF frequencies. Power measurement equipment varies greatly in price, and the equipment being used in today's video is a Nissei RS-70 HF digital power and SWR meter. This meter covers the 1.6 to 60 MHz frequency range and is capable of reading power up to 200 watts, costing around £85. A Metropwr FX775 with an FX3 Coupler covering 1.8 to 55 MHz frequency range and is capable of reading power up to 3000 watts, costing around £650. And a Bird 43, well, a 4314 Thruline RF directional watt meter which has a peak kit fitted. This meter uses slugs, which are plug-in elements that dictate the power and frequency the meter can read and are easily swapped in and out. In these tests we will be using a 25 to 60 MHz 10 watt slug, and these units cost around £900. The Metropwr FX775 does a lot more than just read power and can be connected to antenna switch couplers that allow you to switch between antenna using the 7-inch touchscreen and has some neat additional features. It can also read average and peak power. The Bird 43 looks like it comes from a Soviet power station from the 1950s, but is generally accepted as the gold standard in measuring power output accurately. We will be using this as our benchmark today. The radio being tested today is a Midland M-30, which is a standard CB radio. There are 2 main types of power measurement supported by test meters: average power and peak envelope power, otherwise known as PEP or peak. So which reading type should you use? Well, that depends on the type of modulation you're using. FM and CW are measured using average power, whilst single sideband and AM are measured using peak. FM and CW do not modulate the amplitude and are continuous signals, so the average of something that doesn't change should match the peak reading. FM and CW have a 1:1 ratio, but AM is between 2 and 3 to 1. When measuring AM, there is a carrier signal which is constant, but the voice signal is then combined with the carrier, and this fluctuates dependent on the voice signal. If you talk quietly when transmitting, the power reading will be lower than if you shout into the microphone. The louder the voice signal, the more power is required. So this is why AM typically has between a 2:1 or 3:1 ratio, because the amplitude is being modulated. In a perfectly symmetrical and 100% modulation of a carrier, this would be closer to 4:1. The peak reading is taken by analysing the highest peak of the wave over a given time and shows the maximum power output of the modulation envelope. Average power is a measurement of RF power, which is the average of the power reading over a given time. CB Radio in my region has a 4-watt power limit for FM transmissions, which is easy to read as it's a continuous signal, where the amplitude doesn't change. AM has an ERP, an effective radiated power limit of 4 watts for double sideband modulation or 12 watts peak envelope power for single sideband. This means that for AM you cannot output 4 watts and use an antenna which gives a 6 dB gain, as an ERP would be much higher than 4 watts, closer probably to 16 watts. Now we have to talk about single sideband, as many power meters don't support reading power using this mode. I have included this section in the video just for completeness, as we shouldn't ignore it, but you can skip over this section if you like. Single sideband has 2 modes, upper sideband and lower sideband. A standard CB transmits using both upper and lower sideband, and this is referred to as double sideband. When transmitting using double sideband, the signal is duplicated in the upper and lower side of the center frequency. When using the single sideband mode on your radio, you can choose which side of the band you want to use. When setting your radio to upper sideband, the lower sideband portion of the signal is suppressed, and you only output the upper portion of the signal, and vice versa for the lower sideband. Now this is where things get crazy. It's not only the opposing side of the band that gets suppressed, but the actual carrier itself also gets suppressed from the transmission. So in AM, for example, the center frequency could be 27185 and the amplitude modulation might be 8 kHz, which would result in a total frequency range of 27.181 to 27.189 MHz for a given dual sideband transmission, with 27181 to just below 27185 containing the lower sideband and just above 27185 to 27189 containing the upper sideband, with the carrier being the center frequency of 27185. The carrier is suppressed from being transmitted along with the opposing band. The receiving radio then reinserts the carrier into the received sideband signal in order to demodulate it. If you have used single sideband in the past, then you'll be familiar with a clarifier and what it does. But for those who don't, a clarifier is needed to fine-tune the frequency, although I'm not 100% sure if it adjusts the reinserted carrier signal frequency or the receive frequency of the BFO, the beat frequency oscillator, but you get the idea. Just because a radio transmits on a given frequency doesn't mean that the receiving radio is also perfectly tuned to the exact same frequency or vice versa. The clarifier can adjust the radio's oscillator to match up with the transmitting radio. If the audio that is being output sounds a little robotic, then you need to fine-tune using the clarifier to get a perfect match. If your power meter does not support single sideband, then you are likely to read 0 power being output when taking a reading. This is due to the absence of the carrier. Single sideband is mainly used in HF communications and for voice transmissions, and is more spectrally efficient as it consumes less bandwidth. It is not true to say that single sideband provides you with 40 more channels over dual sideband, because someone transmitting on channel 19 using dual sideband will consume both the upper sideband and lower sideband frequency ranges, preventing their use whilst transmitting. If everyone used single sideband and there were no dual sideband transmissions, then this would be true. The other advantage of single sideband is that you don't waste power transmitting the unused side of the band and the carrier. You can pump all of the power into the upper or lower sideband transmission. It can also reduce noise due to the reduction in bandwidth used, and there is no advantage technically to which side of the band you select. The radios being used today do not support single sideband and are basic CB radios. So with that, let's get on and do some power tests. This is a Bird 43 Thruline, and this particular model is a 4314. The model 4314 comes with the peak kit installed, which includes an internal amplifier so you can monitor peak and PEP power as well as the standard CW average power. Bird is based in Cleveland, Ohio, USA, and created the Model 43 in the early 1950s and patented the directional wattmeter in 1958. They still make them today, and they look pretty much the same, with the equivalent model being a 4314C. Bird wattmeters are generally considered the industry standard for inline wattmeters and are the benchmark for RF power measurements. There are many different models, but the parts and features are mostly interchangeable. If you buy a Model 43 that doesn't have peak and you want to add peak, you can buy a kit to add this to your meter. Bird launched a competition back in 1996 to track down and find the oldest working Bird 43. The competition was called Quest 43, and the winner's wattmeter was serial number 71, which was built in 1952 and is still fully operational. My 4314 is serial number 987, so it's an early one, probably from the 1950s. The new ones have serial numbers around the 280,000 mark, so you can see how many units they have built over time. Oh, and my unit also has the power cable so that you can charge the batteries from the mains. Getting the power cable with the proprietary connector won't be easy. And that is here. Now, the advantages of an old Bird is that you get a good breakfast in the morning. No, let's not go there, so let's move on steadily. So first of all, we are going to validate this old Bird by using a brand new stock CB radio fresh out of the box and see if we get the readings we are expecting, i.e. 4 watts. For this, we are going to use a Midland M-30. So let's quickly unbox it, set it up, and then run through how it's all connected together. So this is the Midland M-30, which is a brand new radio straight off the shelf. And never opened this before, so nice to see you get some stickers with it. This is not a review of the M-30, but I couldn't resist because you get an optional extra saucy lady in the box as well. So that's lovely. So let's get this out of the box. The radio itself. And the microphone, which for the Midland radios unfortunately has a RJ45 type connector, which is a bit of a shame, but there we are. So let's get all this rubbish out the way. I'm going to get it all set up and connected to the old Bird, and I'll run you through how it's all connected together before we do our power test. So we've now set the radio up and connected it to the Bird wattmeter. The M30 is connected directly to one of the ports on the Bird, and the other port is connected to a dummy load. This is a 100 watt 50 ohm dummy load. And we have a 10 watt 25 to 60 megahertz slug loaded in the Bird, and because it's 10 watts it's using the lower scale here. You move the decimal point back by 1, so 40 becomes 4. So effectively, using a 10 watt slug, if the needle points to 40, that's 4 watts. So let's go ahead and take a power reading on FM, channel 20 midband, and see what we get. So we get a 4-watt power reading there from the radio on FM. Now, just for the fun of it, let's switch the direction backwards. So we've just measured forward power, and this will now measure reverse power and make sure that there's nothing horrible going on. So there's absolutely nothing there whatsoever. Just in case somebody says you need to take your reverse power off your forward power in order to get your true reading. Well, it's going to a 50 ohm dummy load, so we have no reverse whatsoever. So the forward power is our power reading. And the power reading for FM is 4 watts on this radio. So let's now switch to AM. So we're now in AM mode, and we are going to switch the bird to read peak, not average, and we'll see what the carrier is registering as. So that's settled down to just slightly over 4 watts for the AM carrier, and we'll now change the 10-watt slug and drop in a 25-watt slug, and we'll pump a tone in and see what we get. So the carrier should register 4, but then we are with the 25-watt slug, we're on the upper scale, so we would expect it to be around here as 4, and then we'll put the tone in. So in AM, with a continual loud tone into the microphone, we appear to be pushing about 12 watts. Okay, I'm going to switch the radio now over to UK mode, and we'll do a quick power reading on FM UK. So we've switched back to a 10-watt slug, we've switched the radio over to FM UK, and we'll take our power reading. So just a little bit over 4 watts in total. So these will be our benchmarks using the old bird and a new fresh CB radio straight out of the box, which you would imagine would be set to 4 watts across the board, and that's certainly what the old bird is telling us. So we've now switched over to the Metropwr FX775. Which is a really interesting unit. It has a 7-inch touchscreen and provides a power and SWR meter along with a frequency counter and various other options. This unit can measure PEP and average power and does this via an external coupler. The coupler fitted today is an FX3, which can measure power up to 3 kilowatts. You can also purchase additional couplers that can switch between antenna using the touchscreen, which is very useful in a ham radio setup, but not so much for CB. Before we start, I must say that I had a few issues with the firmware on the FX775. I noted down the installed firmware when I opened the unit and set it up initially, and it said it was an FX775 version 3 firmware version 18.0. I downloaded and installed the latest version from their website, which was simple enough to do, and when checking after the update, it said it was an FX775 V2 firmware version 12.66. So I contacted their technical support, and I have to say they were brilliant. They responded quickly, they were very helpful and really friendly. They sent me the original firmware that the unit came with so I could reflash it, which I did. However, checking the website just now, they still don't have the V3 firmware on the site available for download. So watch out you don't fall into the same trap as I did on this. So let's run the same tests on the FX775 and see what we get. So one useful feature on the FX775 is that when it detects that there is a signal, it automatically switches to the power screen. So we're going to do an FM power test now. And that's showing 2.5 watts with a SWR of 1.1. So in order to do our AM test, we need to switch the mode to PEP. So we switched over to peak and we'll do our AM carrier test. 2.55 watts there, and next we'll do the tone test. So about 6.7 is the reading we're being given there. So I'm just going to switch the radio over to FM UK and we'll do the test there as well. So the radio has been switched over to UK mode, channel 20, FM, and let's see what we get. 2.5 watts with an SWR of 1.11, and I did switch the mode to average for this. Another interesting thing that this FX775 has is a dBm meter as well, which we can switch to and then key up, and it gives you the dBm and wattage. So this is the FX3 Coupler that the unit uses, and we have the input from the radio into the inside of the coupler, and on the outside we're going out to the dummy load, and there are two connections here which connect to the back of the box. Now you can't make a mistake here because there are colours on the back here and they correspond to the same channels on the back of the box. So let's switch over now to another power meter and see what we get. This is the Nissei RS-70 digital SWR and power meter. It measures forward and reverse power and displays both and calculates the SWR. Nissei is a Taiwanese company specializing in meters and power supplies. According to the internet, they were established in 1967 and employ over 100 people and have 10 production lines. The RS-70 covers frequencies between 1.6 MHz and 60 MHz, so should be ideal for CB frequencies. It can read power up to 200 watts. It's a small unit, but a very hungry one. It eats batteries, so plug it in via a USB cable whenever you can. So let's crack on and undertake the same power tests with the RS-70. So let's undertake the usual power tests that we've been doing. We're in FM, and let's see what the RS-70 gives us. So 3.06 watts with an SWR of 1.0, which is perfect. Switching to AM. Around about 3 watts for the carrier, and we'll do a tone test. About 6.8 watts. So we'll now switch the radio over to FM UK and do a test there. So we're in FM UK. 3.2 watts with an SWR of 1.0. So that's all of our power meters tested, and let's have a look at the results of those meters all together. So what do these results tell us between the meters being tested? Well, the bird agrees with the radio's screen. I don't know if you noticed during the tests, but the Midland M-30 has its own power meter at the top of its screen, and that agreed with the bird in all of the tests. Both the FX775 and the RS-70 give completely different results and show much lower power outputs. Looking at FM, the FX775 shows 2.5 watts, the RS-70 shows 3.06 watts, and the bird and the radio show 4.0 watts. So there is a 46% difference with the FX775 and a 26% difference with the RS-70 in that particular test item. Now let's see how these differences could end up causing you problems. I have tuned this President Barry 2 to the 4 watt legal limit using the FX775. So let's go ahead and have a look at those numbers now. So we're in FM mode, 3.9 watts, and we're using average power. Switching over to FM UK, 3.9 watts. Switching to AM, and PEP, so about 3.9 watts, although we get a peak at the start. And then if we do the tone test, about 10.75. So those are the numbers. You've tuned your radio and you believe you're completely within your legal limits that your country has set. Now let's connect it up to the bird and see what we're actually outputting. So we've connected up the old bird. She's coming back out for an outing. Apart from smelling a little bit of lavender and piss, she's having a lovely time. So we're on FM and let's see what sort of a reading we get. So that's about 6.2 watts on FM. FM UK, about 6.2 watts. Switching to AM, we're getting about 6.2 watts, and in order to do the tone test we're going to have to switch the slug over to a 25 watt. Okay, 25 watts in. And let's do the tone test. So that's about 17 watts showing on the bird. So tuning the radio or a radio using an inaccurate power meter could cause you a few problems if your radio was ever tested and you were found to be exceeding the 4 watt legal limit and the 12 watt limit for single sideband. So what have we learnt performing these tests? Well, not all power meters are the same. There can be large differences between the readings. Which meter is right and which meter is wrong? That is a really difficult one to answer. What do you think? Which meter would you trust to be accurate? Please leave a comment with your opinion below. The FX775 does have a 3 kilowatt coupler, so is more likely to be less accurate at the lower power ranges. Maybe in the future they could create a 200 watt coupler for HF frequencies, which has a more accurate lower end. The FX775 also displayed an SWR reading of 1.1, which doesn't agree with the RS-70. I also measured the SWR on another dedicated SWR meter, and that also showed 1.0. The RS-70 is the most convenient to use due to its size and clear digital display. I really don't want to be unfair to any of the manufacturers here, but for power testing going forward, I will be using the old bird. An oldie, but a goodie in my view. I hope you found the information in this video helpful. If you did, then please help me out by giving it a thumbs up and subscribing to the channel. This really does help and ensures that I can continue to provide content. Please feel free to buy me a coffee, details are in the description below, and if you have any questions or comments, then you know what to do in the comments below. All I ask is that you keep it respectful. Nasty know-it-alls need not apply. Until next time, stay safe, stay happy, and catch you in the next one.